So welcome back. I know I've promised to implement some more of the game and to make everything running, and I promise I will. But there's actually something I think is much more important, and I think it's good to get used to doing it from the start. And this is testing your work. And I'd like to illustrate why I think this is so valuable using this graph that I pulled off of Google. There's a copy right here in the bottom right, and I'm just gonna explain what it shows. Here on the bottom, on the x-axis, it says length of feedback cycle, which roughly means time until the bug has been found. And here on the y-axis, it's cost, which is time that it's going to cost you to fix the bug. And you see all the way at the bottom left, if you find a programming defect via pair programming, which is programming in couples, you have somebody watching you, or programming defect found via continuous integration, which is you always test everything immediately. This is what I usually do. There's basically no real extra time to debug your program. And the further to the right you go, the longer it takes to find it, right? If you find it via traditional acceptance testing, the customer has to find the bug for you. It's going to take, maybe, sometimes it's going to be 20 times, sometimes it's going to be 100 times. It's going to be a lot more work to fix it. On top of that, it's also going to be a lot, you know, is your customer's not going to be happy to find bugs in your program, really. So there's those things, and the reason it takes more time to fix a bug after it's been after a longer time is because there's two things really. First is you're not going to be as acquainted, as used to the code as you were when you just wrote the bug, right? The longer ago it is, the more back in your memory it is, and the more difficult it's going to be to understand what is happening. The other thing is, the longer ago the bug was created, the more new stuff that has been added to it, and the more stuff that is reliant on your code. So the buggy code, fixing that is going to have to also fix more other pieces of code, perhaps. So this is why it's really important to find as many of your bugs as early on as possible. And for the people saying, well, just don't make bugs, trust me, everybody makes bugs, so do you. So that's why we're going to do some continuous integration testing today. The first thing to do is we're going to create a new branch. So we're going to go to project, we're going to go plus, new branch. I'm going to call this add feature unit testing. And I'm going to go from development, create branch. I'm going to pull, git pull, git checkout feature unit testing. And we're going to go to our pycharm. I'm going to go with the Space Invader one first. And I'm going to say right click, go to test, create new test, and we're going to select all three. Add this. Now what does this show you? This is the class test Space Invader, and when you run this, I'm going to just run one of these. It tests if this test is correct. Well, it says self.fail, so surprise, surprise, it fails, right? And you see in between brackets that it inherits from unittest.testcase. So there's a lot of functionality, a lot of functions that you can actually use without writing them yourself, which is really nice. However, I'm going to change a little bit of stuff here. I'm going to say import unit test. I'm going to say at the bottom if name is main unittest.main. Now if we run this, it checks all three tests. Something else we're going to need is we're going to have to import the Space Invader class. So from core dot Space Invader import Space Invader. Now before we continue, I see I created the test in the core folder, which is wrong. I want to be in the test folder. So I'm going to move it, and pycharm takes care of everything for us, so that's great. And I'm going to add a new function, def setup self. What does this do? This is run before every function. I can show you. Print a, print 1, print 2, print 3. Let's run this. And see, it goes A1, A3, and A2. What you also see is that the functions, the tests, aren't necessarily done in the order that they're written. So that's something important to keep in mind. These tests need to run entirely independent from each other. Because if the order matters, they're not always going to be in the same order, so you're not always going to have the same unit test, right? So make sure that your tests are not dependent on each other. The setup is run before each test. So you'll run setup, test update position, setup, test reached bottom, and setup, test get hit, or any other order of those three functions, right? So I'm going to create a self.spaceInvader object. Self.spaceInvader is Space Invader. Health is 100. X coordinate is 0. Y coordinate is 100. Speed X is 10. And Y incrementation is 10. We're going to say self.screen width is 50. And we're going to write our first test. I'm actually not going to do these two because I don't think it will be that interesting. I think it's also going to take a lot of time. So I'll do these in the next video. Or I might just do them. I'll do them in the next video. So the first thing to do is we're going to go. Let me just get this out of the way. We're going to say self.spaceInvader update position. Screen width is self.screenWidth. We're going to say self.assert equal self.spaceInvader .x coordinate, and we know we start at 0, our speed is 10, and we do 1 incrementation, so our Space Invader moves to 10. And self.assert equal self.spaceInvader, too many brackets, self.spaceInvader .y coordinate 100, because we do not drop, right? And we can add a message here. Message is standard update. Message is standard update. So if this goes wrong, this will be printed, so you know the standard update is wrong. Now next thing we're going to print at check. We're going to add a comment here to say check if moving once works, and we're going to now also add a check if moving down and the other direction works. So let's first test this by hand. So we expect to go from 10 to 100 to 20 at 100 to 30 and 100 to 40 and 100 to 50 and 100 to 50 and 90 to 40 and 90, right? That makes sense, right? Because we go from the left to the right, but our y value, this is our y value, doesn't change. Then we get to the edge, we go down 1, and then we go the other direction. So let's make a list. So correct coordinates is So my screen recorder quit there, so let me just yeah, sorry about that. But we add these to the correct coordinates and say for correct x, comma correct y in correct coordinates, self.space invader, update position, screen width is self.screen width, and we're gonna copy this here, add it on here, and this becomes correct x, this becomes correct y, and I also have to change the message, so testing, test move across and back. So if we run this, it says ran one test in 0.004 seconds and it's okay. So I hope that makes sense, and I hope you also understand why this is useful, because it, if this function ever gets changed, it will become immediately apparent when you run this that your function is no longer correct, or at least it no longer functions the way you expect it to function. So that would be, a reason to go check that out. Either way, that's the end of this video, and I hope to see you